Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross, and today we're going to do some calculations and discover what density is all about. My assistants this morning are Melissa and Catherine. Melissa, what is density?
How dense something is.
How dense something is? What's that mean?
How thick it is.
How thick it is. In other words, if I were to take this box, right, a little container, and it has a certain amount of material in it right now, right? So we take a look at it, and it has a certain density. If I put more material in it and don't make it any bigger, right, what happens is the density goes up, density increases. So what it really amounts to is I've got a certain volume, which this box is, right, and a certain amount of material inside the box, if you will, and that determines how much density. I dump everything out like this. What happened to my density?
It went down.
It went down. If I put more stuff in it, now what happened to my density?
It goes up.
It goes up, right? Did I change the size of the box?
No.
Nope. All right. So we have a mathematical formula for density. You know what it is?
Mass over volume.
Mass over volume. Density is equal to the mass, right, or how much material there is divided by
Volume.
the space that it takes up. So if I were to take this piece of wood, right, it has a certain volume and it has a certain mass, and if I divide its volume into its mass, I end up with the density of this piece of wood. Here. What's this?
Graduated cylinder.
It's a graduated cylinder, and it's the reason that we call it a graduated cylinder because it has little marks on it, all right, and it's graduated, it's scaled in milliliters, a thousandth of a liter. In other words, each one of these little marks is 1 milliliter. If you were to go off and get a liter bottle of soda, you would have 1,000 milliliters in that bottle of soda. Right? So that's a graduated cylinder. We're going to use that for measuring things. Okay? Basically for measuring the volumes of liquids. Well, you want to describe that for me just a little bit? This one here, that we have a graduated cylinder with,
A density column.
all right, it has all these different colored things in it. Would you like to explain that, Melissa?
Okay. I'm Catherine. We built a density column, and they're all different substances. There's dishwashing soap, and
Dye syrup.
yeah, there's
Oil.
syrup, oil,
Rubbing
and
alcohol.
rubbing alcohol.
Right.
And they just show how dense.
So which one's, yeah, all right. So that's a density column. Which one's the most dense?
The
The
dark.
dark.
The one down on the bottom, right?
Yeah.
Right. Because when we poured it in here, it sunk all the way down to the bottom, so we know it's more. We know it's more dense. Right. What about this one up here?
It's the lightest.
That's the lightest, the least dense, right? Right. And what about this one? The density of this one is sort of in between that one and this one. Can we tell from this density column exactly what the density of this is?
No.
No.
Or this, or this, or this? No. But we can calculate that. Right? So what we're going to do is I have an empty graduated cylinder here, right? And we can measure the volume, right, by looking at how many milliliters there are, right? And then we can weigh it to get its mass, right? But if we were to fill up this thing with water, right, and weigh it, what we would be weighing? We'd be weighing the weight of the graduated cylinder plus the water that was in it, and what we really want to know is what the water weighs. Right? So we're going to start out. Okay, we have a scale, and I want you to measure or weigh, find out what the mass of my
39 grams.
39 grams. So Catherine, you want to write down 39 grams is the weight or the
38.
mass of my graduated cylinder. Right. Water. Give me about 50 or so milliliters of water. How many you got?
50.
50? Exactly? Oh, come on, you're not that good, are you?
Gotta be.
It's pretty close. I'm amazed. How did you do that? Right? 50. So we're going to weigh it again. What's it weigh now?
89 grams.
89 grams. All right. So now then, the graduated cylinder and the water weighs 89 grams. How much does the water weigh?
50 grams.
We'll subtract the weight of the graduated cylinder from the weight of the water.
Right. You're going to subtract the weight of the graduated cylinder from the weight of the graduated cylinder plus the water, and that will give you the weight of the water.
40 grams.
39 from 89 is
50.
50 grams.
Okay.
Okay, 50 grams. So the water weighs 50 grams. How many milliliters are in there?
50.
50. So how are we going to find out what the density of that water is?
We divide mass over volume. We divide volume by mass.
Okay, so we're going to divide volume by
Mass.
the mass. The mass is 50. The volume is
50.
50. So what's that work out to be? What's the density then?
1.
Density is 1, right? So write it down. Density of water is 1. All right, let's do one other little thing before we go any further. All right, I have a little cube. I mean, it's a funny shaped little cube. It's got some holes in it and it's got a little thing on the end of it. But how am I going to find a volume of this little cube?
Length times width.
Length times the width times the height. Well, you want to measure it? We have a centimeter tape there. Can you measure that?
1. It's all 1.
It's 1. So the length is 1, the height is 1, and the width is 1. So 1 times 1 is what?
1.
1. And times another 1 is
1.
1. So it's 1 cubic centimeter. That's 1 cubic centimeter, right? With the exception for the little holes in it, right? So it doesn't really take up 1 cubic centimeter of space, but it's pretty close, right? So what I've done, how many are there?
1, 2, 3, 4, 5.
I put 5 of them together, and then what I did is I pasted the little holes over, right? So we get rid of them. Now then, what I'm going to do with this is I'm going to drop this. How much water was in here?
15.
Yeah.
50 milliliters,
Milliliters.
right? And we're going to put these 5 cubic centimeters of little cubes in here. What's the volume now?
55.
It went up to 55. So when I put 5 cubic centimeters of little plastic cubes in there, this went up 5, right? In other words, that displaced 5 milliliters of the water. So each one of these cubic centimeters is equal to what?
1.
1 what?
Milliliter.
1 milliliter, right? So when we start calculating our densities, right, we can either use milliliters or we can use cubic centimeters because they're basically the same thing. If it's a liquid, right, we can put it in the graduated cylinder and find the volume in milliliters. If it's a solid, then if it's a cube like this one, we can measure it, right, and calculate what its volume is going to be. Or if it's some funny shaped thing, like this little lead sinker, right, that's pretty hard to calculate, right, because I have all kinds of measurements. It's big on the fat on the bottom, it's skinny on the top, right, and for me to be able to measure that accurately and calculate its volume, it's going to be a little hard, right? So what I could do with it then, if I want to know exactly what its volume is, what am I going to do?
Put it in the water.
Well, put it in the water, right, and see how much the volume of the water goes up, right, and that would be the volume of this. All right, so we get things out of here. Get my cube out. Just give us 50 milliliters again. Or no, just give me 100 milliliters. That'd make it even better. weren't so close that time, huh? You're good with those little numbers like 50, but when it gets to be big numbers like 100, it's...
Yeah.
All right, do me 75 instead.
Make up your mind.
Yes, ma'am. What is it?
65.
All right, that's close.
Okay,
We can
65.
stop there. We don't have to get it exactly right, because we're going to use that as the place where we start. Now, if I want to find the density of this piece of wood, what do I have to do?
Find the mass and the volume.
Find the mass and the volume. Well, I can't put it down in there and displace water, so because it doesn't fit, right? So how am I going to find the volume, first of all?
Length times width.
Well, length times the width times the height, right? In other words, what I'm going to do is I'm going to use this little diagram here. I'm going to take the length and the width and the height, take those measurements, and I'm going to multiply them together, and that's going to give me the volume of this piece of wood. So, Melissa, you measure. Catherine, you record, and I'm going to take a nap. Now
Length.
do it accurately.
12
12 what? What is that?
centimeters.
12 centimeters, is that the length, the width, or the height?
The length.
That's the length, okay?
Two for the width.
All right, 2 centimeters is the width, and
Height is 3.
the height is 3. All right. So, what's the volume now? Catherine, use your calculator there if you want.
Okay, so we gotta add them together, right?
Multiply.
Okay.
Length times the width times the height.
So
72? 72 cubic centimeters. All right, write that down. Let's record that. All right, Melissa. Weigh it.
47 grams.
47 grams is its mass, right? So we're going to take its volume, which was what, 72, and we're going to divide it by the mass, which is 47 grams. So,
a lot of numbers.
all right. So you're saying the density is 1.53. So the density of this piece of wood is 1.53. No. I have a question. You weighed this and it was what?
47.
47 grams. A couple of years ago, I weighed it and it was 50 grams. That's why this number is written on here, 50. What do you think the difference is in that piece of wood?
3.
From being a year or so ago and now?
3.
Hmm?
3.
It's okay. It's 3 grams difference. Why is the weight different? That was a tricky question. You have a guess why the weight might be different now than what it was a couple of years ago when I weighed it originally?
I don't know.
You don't know? Let me tell you. Right. What has happened is it's dried out some more, right? Originally when I weighed it, it had a little bit of moisture in it, right? Which raised its mass, right? Because it had some water in there, right? And water is a little heavier than wood, so what it was is this weighed like 3 grams more. Since then it's dried out considerably, so now then it's
47.
47, right? It lost 3 grams. It's like if you took me and dried me out, squeezed all the water out, I wouldn't weigh as much either, so. But now, right, so our density of this piece of wood is what?
1.53.
1.53. All right, let's put that down. All right. We have another piece of wood. How are you going to find the volume of this piece of wood? Well, let's just look a minute. All right. what we did, when the square piece, all right, we multiplied the length times the width, right, which was length times the width. All right, when we do that, what do we get? We get square centimeters, right? And what we're doing is we're getting the area of this
So
part.
we gotta get the radius from that one.
Ah, right. So what we need to do is we can say, okay, this is the same, this surface here is the same as this surface here. So if we knew the area of this, right, which would be the same as multiplying its length times the width, right, and then we multiply it by the height, we would get the volume. Right? So we need to find the area of that circle. Right? And what we will get then, when we do that, is how do we find the area? How do we find an area of the circle? Remember the formula? It's area is equal to pi times the radius squared. Remember that funny pi thing? Okay. So what we need to do now then is we need to measure the diameter of our circle.
Three and a half
3.5, what?
centimeters.
3.5 centimeters is the diameter. Right, so what's the radius? The radius would be what? Radius is half of it, right? So it's half of 3.5, so the radius would be, Catherine, what's the radius? What's half of 3.5? Do it on the calculator. Take 3.5 and divide by 2.
1.75.
1.75. All right, so my radius is 1.75. And what's my formula for the area of that circle? It would be the area is equal to pi, which is 3.14. Let's multiply 1.75 times 1.75 for square the radius. And then multiply that by 1.75. So what's that area?
It's not working. $5.45.
5.45?
No, 5.495
5.495 square
centimeters.
centimeters. Okay, what's the height of our cylinder now?
Ten and a half.
10.5, right? So multiply 5 point whatever it was times 10.5. So what's our volume now?
57.6975.
57.69 cubic centimeters, right? What's its mass?
$70.
70. So the mass
Grams.
is 70 grams, and our volume is what? So what now then? Tell me what the density is.
So 0.0785.
All right. 0 what?
.0785.
Okay. All right. So that down. Now then, we need to find some densities of some other things. Let's pick something. A bolt. Melissa, I want you to measure that. Tell me so we can calculate the volume.
We can.
Put
We
it
have
in
to
the
put it on
water.
the cylinder
Mm-hmm.
Why do I have to do that? Why can't we measure that?
Because it's an odd shape.
because it's thick air.
Well, I have a cylinder here, right? But it's got all these little threads on it, right? So I can't measure down in there, so I can't get a good accurate measurement on that. And then it goes up here and it's square. I've got a little thing, and then this is all round, so it's going to be pretty hard, right, to measure that. So you were suggesting I do what?
Put on the
Drown it
cylinder.
in the water?
Yeah.
Right, but before I put it in the water, should I measure it or weigh it? Get its,
Yeah.
Yeah.
Because it's gonna
Why?
get wet and the water's gonna make it heavier.
yeah, if I throw it in there and then take it out and try to measure it, it's going to be heavier because it's going to be wet. Okay, so we're going to put it on here. Melissa, my bolt weighs what?
37 grams.
37 grams. Right, now before you put it in there, don't put it in there just yet. How much is that?
66.
Right.
67.
67. Right, now then you can plunk it down in the water.
Shoot. 71.
71.
Yeah.
And how much do we have on the table? Huh? Let's try this all over again. Right? It still weighs the same, right? Because we've lost maybe a milliliter. We're going to be off a little bit, so. But that's good, right? There's nothing wrong with that. We know not to plunk it in there again, right? Give me some more water. Put it at about half full, about 50 or so. All right, what's in there now?
49.
49. All right, I'm going to put it in so that we. So it's 49, and I'm going to add the bolt. And I lost some water too, right?
$54.
So it went from 49 to 54. So what's the volume of the bolt?
5.
Right, 49 to 54. So the volume is 5 milliliters of 5 cubic centimeters, right? So we got volume of 5, and our weight was what?
37 grams.
37 grams. So we take 5 and divide it into 37. We take the volume and divide it into the mass, and we're going to end up with the density of my bolt. All right, do that while I'm playing in the water.
So we're gonna like this.
5. 7.4.
7.4. So the bolt is 7.4. Right? You can remember all the numbers now because we're going to go back later on and check. Okay, let's do another one. Right? Melissa, give me the mass of, what is that thing anyway? You know what that is? Hmm?
Nope.
All right. Its mass is what?
47 grams.
47 grams. Right. That is a lead sinker that you would, since it's springtime, it's time to go fishing, right? And that's a sinker you use to make the bait go down into the water, right? To where the fish are. And you don't want it all floating up on top necessarily. All right, so what did you say the weight was? The mass?
47.
47. All right, now then how are we gonna measure its volume?
From the graduated cylinder.
Put in the graduated cylinder. How much water is in the graduated cylinder now?
72.
72. All right. And how much does it?
76.
76. So 72 to 76. The volume of that sinker is what?
4.
4. Right. So put the volume down as 4, and we're going to divide 4, the volume, into.
The blue is 4, right?
4.
4.
Right. And we're going to divide it into the mass, which was. What was the mass?
47.
47.
11.75.
11.75. What do you think that sinker is made out of?
Lead.
Lead? Is that the same thing that's in a pencil?
Yeah. No?
No, it's not. Right, this This is actually lead, all right, and it's probably actually a little alloy. It's mixed, this lead mixed with something else. The stuff that you have in the pencil, right, is really graphite and clay. Back in the, originally, it was lead because we take this, if you look at it, what's it do? We made a little mark, right? So, but it's not a very good little mark, right? And today's pencils, the thing that we call lead is actually graphite, which is carbon, and some clay mixed together, right? There's a binder to hold it together. All right, so what did we say the density of this sinker was?
11.75.
11.75. Okay, so let's do something else. All right, so next let's see if we can find the density of that little bouncy ball. The first thing we want to do, obviously, is to weigh it. How much does it weigh?
8 grams.
It weighs 8 grams. No. All right, so it's 8 grams. The bouncy ball is 8 grams. How are we going to find its volume?
Put it in the cylinder
Why would you want to do that?
and see how much the water goes up, and then that's
Well, if we knew what its diameter was and its radius, then we could use the formula and figure out what its volume was, right? So we could, if we had something where we could measure it, but we really don't have anything to measure it with. It's very accurately. So we're going to do like you suggest. We're going to put it in the water, column of water here, and see how much water it displaces. What's it read now?
85.
85. Now what's it read?
94.
94, but you have a problem, don't you? The little bouncy ball is not all the way down in the water, so it's not displacing the ball, and you can't reach it with your finger, so what do? I'll show you what we're going to do. First of all, we're going to get it out of there. All right. Let's see if we can get it out without making too big of a mess. All right. Put some more water back in it. Bring it back up to 85 again. I'll let you do that. Okay, it's 90. All right, so what we need to do is we need to find some way to push the ball down in there, and you can't reach it with your finger. But I got a little tiny piece of wire, which is really good because it's not going to take up much space. And what I'm going to do is I'm going to stick it in the ball like that. Now then, all you have to do is push it down in there, under the water. What was it? It was 90,
Yep.
right? Now what is it?
99.
99?
Yeah.
So it has 9 milliliters then of volume. And it weighed how much? What was
8.
this mass? 8?
8 grams.
All right, so what's its density?
1. I think it's 1. 1.1.
1.1?
2.5.
All right, so, but we didn't think that's right? Let's try that again, because I'm not sure we got the volume exactly right. Right, because how do I know it's wrong? How do I know our answer was wrong? Because what happened to it when it floated in, when I dropped it in here? It floated, right? It floated up to the top, and that means the density is less than the density of water. And what was the density of water?
1.
1. So it's got to be less than 1. Right, so what we need to do is we need to very carefully read that. What is it? Is it exactly 90?
It is 88.
88? All right, so we have 88 in there now, and it's 99, so
It's 98.
98. All right, so what's the volume?
10.
10. And we're going to divide 10 into 8 grams and gives us what? For the density.
0.8.
0.8. Ah, so it's less than 1, right? First time we did it, right, we didn't read the volume when we started out with the water just exactly right. All right, so that's 0.8. No. You know what this is?
Medallion.
It's a medallion. It's called a cartouche. A big word, huh? That's a little Egyptian medallion, right? Supposedly it's made out of gold, and it has some hieroglyphics on it, which happens to be my wife's name, right? We borrowed her locket of it, cartouche. And how much does it?
9 grams.
It weighs 9 grams. All right, now I know how are we going to find the volume of it? How are we going to find the volume of the cartouche?
Put it in water.
Put it in the water. All right, what were you going to start off with? How many?
88.
How much?
88.
88. So let's start with 88. I'm going to drop it down in there.
89.
It goes to 89. So we've got an increase of 1 milliliter, so the volume is 1. The mass was 9. So 1 into 9, what does it come up to be?
$0.1.
Hmm?
0.1.
0.1. 1 into 9 is 0.1? You did it backwards, I think.
9.
9. Okay, so the density of that cartouche is 9. All right. So let's see if we can get the cartouche out of there without making a big mess. And put some water in there. All right, so let's do, well, that thing hangs on a chain around your neck, so let's weigh the chain. Let's take the
10 grams.
10 grams, right? And how are we going to find the volume of the chain?
Put it in the water.
Put it in the water. All right, how many milliliters of water do you have?
70.
You have 70 exactly?
Yeah.
All right.
71.
71, so we went up 1 milliliter, and what was the mass? How much did it
10
weigh?
grams.
10.
10, so 1 into 10, so what's the,
10.
10 is the
Density.
density. All right. Okay, let's do one more. Okay, we have to do that. We get that out there later. But anyway, so no, what's that say?
Salt water.
Salt water. All right. Now this is a saturated solution of salt water. You did an experiment up in the classroom where you kept putting salt in the water and see how much it would dissolve, right? And you put enough in there to where it didn't dissolve anymore. Well, I did the same thing. So there's a little salt down on the bottom. So I have some salt water, right? If you look at it, you can't see any salt floating around up in there because all the salt molecules go on in the solution. So what I want you to do is I want you to put some salt water in the cylinder. All right. So what do you think is going to happen to the density of the salt water? Look at the water when we've added salt to it. Is it going to be more or less than just plain old water?
I say more.
You're going to say more? Why? Because there's salt in it, right? We've had, when you were doing that experiment and you kept adding the salt, and they kept adding the salt, the water didn't get any bigger. You didn't get any more volume of water. What happened is the salt molecules were going in between the molecules of the water and taking up the space. So we've got how many milliliters of water in there now?
60.
60. And let's weigh it. Do we remember what the cylinder weighed? It weighed 38. So what is it?
110 grams.
110, and our cylinder, when we measured it, weighed 38 grams. Right, so we subtract 38 from 110, and that's going to give us the weight of the salt water, or the mass of the salt water.
72.
72 is the mass, and the volume was what?
60.
So 60 into 72 is going to give us the density.
One point two.
1.2. And water was what?
One.
Water is 1, so it's more dense, right? So, now then, let's go back. What we did before was we started out, I believe, with a block of wood, didn't we? Right, and we found its volume by measuring its length, its width, and its height, and multiplying those three together and come up with the volume of the wood, right? And then we weighed it and we divided the volume into the mass, right? And that give us the density. What was the first one we did? Will you go back and look and see what the density was?
Of this?
Of that one, right, the first one.
All right. It was 1.53.
1.53? All right, so down here somewhere, there should be wood. Where is wood? Way down at the bottom, right? And the wood is from 0.12 to 0.72, right? Is the sort of the general range of wood. Why do you think they give us that range? Because not all wood is the same, right? Some wood is much heavier than other wood. And we had what? What was our density?
1.53.
So our wood was a little more dense than theirs, right? And that's possible because our wood may not have been as dry as the wood they were using, right? They may have had a little moisture in it and so forth. What was the next one that we did? We did the cylinder, right?
Yeah.
We did this one. And what we did is, on this one, is, first of all, to find the volume of it, it won't fit in the graduated cylinder. What we did is we said this is a circle, and we found the area of the circle by using the formula, right? Pi r squared. Right? Found that area, and then we multiplied it by its height and got its volume, right? So what did we find for the mass of that one?
The mass of that one was, I think I didn't write it. The area was 5.495.
Okay. And we didn't get the mass written down? Okay, well, it's going to be about the same, all right?
Yeah.
So what's the next one that you have there?
We had another, the sinker.
Yeah.
We had a sinker, do we have this?
Yeah.
Right? Which is made out of iron.
Yep.
Right? And it's an alloy. You know what an alloy is? Right, when you did, it's sort of like a solid solution. You did solutions where you mix two liquids together and they went into solution, right? Or you put the salt in the water and the salt dissolved into the solution. Well, an alloy is like a solution of metals, right? So this is not really pure iron, right? It's probably a mixture of iron and some other metal. We don't know exactly what because I can't read the markings on the bolt, but so this is not really pure iron. If it were pure iron, it would be, density would be 7.7, right? So what did we get for it? Do you have that written down there?
7.4.
7.4. So we're pretty close, right? So that we're in the right ballpark. We're doing pretty good, right? What was the next one we did?
The sinker.
The sinker, right? This thing, right? And this was lead, right? And what is the density of the lead?
11.75.
11.75, right? And our lead here was, what was it?
11.3.
11.3, so we were pretty close. You know, we were going to be off a little bit, right? Because if we were to really, what we should have done is done it like 3 times, right? So that we could make real accurate readings, right? And come up with the average, and we probably would have been a bit closer. What was the next one we did?
The ball.
The ball, right? And we come up with a density which is what?
0.8.
0.8. Do we have a plastic on here somewhere? Probably not. Right, so, but anyway, that's probably pretty close because there's all kinds of plastics. We knew that this floated in the water, so it had to be a little less than 1, right? So 0.8 for the density is very good. Now, then we did the cartouche, which I put in my pocket, right? That's supposedly gold, and what did we come up with?
9.
We come up with 9. All right, well, here's gold. Pure gold is 19.3 for density, right? But pure gold, one of the problems with when you're making jewelry, right? First of all, it costs a lot, right? If you make it out of pure gold. Second, gold is very, very soft. If you had a bracelet made out of pure gold, 24 karat gold, right, it would bend and be very, very soft. You would have a hard time keeping it round around your thing. So, now it's not all made out of pure gold. It's made out of gold plus some other metals which are alloyed in the solution. So, down here we got 18 karat gold is 15.2, right? 8, that's yellow gold. White gold is 14.9 because it's mixed with some other materials. 22 karat is 17, right? And so this is really not a very good high quality gold piece, right? If it were more gold, if it were solid gold, right, the density would be up around 19.3. Right? What about the chain, which is down here in the bottle?
10.
Huh?
It was 10.
It was 10? All right, so it's a little bit better, right? It's still not, it's probably about a 9 karat, right, gold, right? So it's about 10. Right? So, now, what we did is we measured densities of all kinds of things, and we did it all the same way, right? We found the volume, how much space it took up, and divided it into its mass, how much it weighed, right? We did it a couple ways. Liquids, we can use this graduated cylinder and measure the volume in milliliters, right? And if it's a real funny looking shape that was really hard to measure its volume, measure the dimensions on it and calculate the volume, what we do, we dropped it in the cylinder and see how much water it displaced, right? So that, like this is 60 milliliters, we put it in there. If it goes up 5, then this displaced 5 milliliters of water, and we know what the volume is. Now, how do we know that we can do that? Is because when we measured this, we measured it in what? Centimeters, right? Not milliliters. Milliliters is for measuring liquids, right? And this is centimeters, right? So we come up with cubic centimeters, right? And the reason we can use either milliliters or cubic centimeters is because milliliters and a cubic centimeter, 1 milliliter and 1 cubic centimeter are the same volume. And the way we proved that is we took 5 cubic centimeters and we dropped them in there, and the volume increased by how much?
5.
Increased by 5, right? So we know that those are cubic centimeters are 1 cubic centimeter is equal to 1 milliliter in volume. All right, so that's it. Now that you know how to find densities, you get a present with gold jewelry and so forth, you can go find its density and see if it's really 100% gold or if it's something less, right? Maybe it's only 9 karat gold like this cartouche appears to be. Thank you, and we'll see you the next time.